Press the bell icon on the YouTube app and never miss another update.
Hello, good morning students. So welcome to the class. So in last class we have discussed about the formulae in trigonometric functions. So here there are so many formulae in trigonometric functions where each and every formulae, so they are used so in calculus part as well as in this inverse trigonometric function. So therefore let us give importance for, that is the multiple angle 2a formulae and 3a formulae, and then we go for the transformation formulae. So here we know that in particular, so we must know that is sine 2a cos 2a in terms of only tan ratio where we use maximum. We know that sine 2a only in terms of tan ratio is 2 times tan a divided by 1 plus tan square a, and cos 2a only in terms of tan ratio we have 1 minus tan square a divided by 1 plus tan square a. So seeing this such type of terms in the functions, inverse function, so there we have to replace the substitution here in this place, that is if it is in terms of 1 minus x square by 1 plus x square, in place of x we have to take tan a. We have to take x equal to tan a, then we can reduce it to cos 2a. Then tan 2a in terms of, that is only in terms of tan ratio is there, 2 times tan a divided by 1 minus tan square a. And the multiple angle 3a formula, that is sine 3a, we know that 3 times sine a minus 4 times sine cube a, and cos 3a, we know that, so here the cube term must be in the first term, 4 cos cube a minus 3 cos a. Next tan 3a, 3 times tan a minus tan cube a, so divided by 1 minus 3 times tan square a. Here both numerator denominator we have minus sign. So these are the results where we use particularly so many times in inverse function. So now we have to know about the formulae of, that is the transformation formula. That is we know that transformation formula means that the sum or difference of two trigonometric ratios, it can be transformed into the product of two ratios. So similarly, the product of two trigonometric ratios, they can be transformed into the sum or difference of two ratios. To know these formulae, we use the compound angle formulae. So in that method, so if you write it, then we can remember the formulae. So first you consider, that is sine of a plus b formulae. We know that sine of a plus b, so it is equal to sine a into cos b, so plus cos a into sine b, cos a into sine b. And also we know that sine of a minus b formula, that is equal to sine a cos b minus cos a sine b, cos a into sine b. So now when we add these two results, so that means formulae, we get another result, that is adding 1 and 2. So that is adding 1 and 2, we get sine of a plus b, sine of a plus b plus sine of A minus B, it is equal to, so we get the first factor that is in the formula. So the first factor, first term which contains two factors. So we get 2 times sine A into cos A. In the above result formula, we get the first term factors. So we have to write this one. Next, equation 1 minus equation 2, it gives the sine of A plus B. So we have to subtract minus sine of A minus B. Then we will get, so second term result we have to consider here. When we subtract, we get the second term result. That is 2 times cos A into sine B. Cos A into sine B. So similarly, so we have to consider the compound angle formula, that is cos of A plus B and cos of A minus B. Cos of A plus B, we know that it is cos A cos B plus idre minus togobeko, that is sin A into sin B. You take this as equation 3, and we know the result of the formula of cos of A minus B, that is equal to, if we have minus sign here, we have to take the plus sign. The first term factors are both cos ratio, that is cos A cos B plus sin A into sin B. You take this as equation 4 and you take this as equation 3. So here when we add equations 3 and 4, so 3 plus 4 result, so it gives cos of A plus B, so plus cos of A minus B. Then the result that we are going to get is the first term factors, that is twice, it will add up twice cos A into cos B. Next, equation 3 minus equation 4, so it gives, so cos of A plus B, cos of A plus B minus cos of A minus B. Then when we subtract, when we take the minus sign, multiply with minus sign for this formula, now the first it becomes minus and this also it becomes minus. When we add, these two results get cancelled and the second term result, they will add up, so with negative sign, that is minus twice sin A into sin B, sin A into sin B. So now we have the 4 results here, that is sin of A plus B plus sin of A minus B, we get twice sin A cos B. Sin of A plus B minus sin of A minus B, we get the second term factors, twice cos A sin B. So now you take this as A, this as B, this result as C, and this result as D. So now we can write, that is, so now you consider those 4 results, that is equation A, B, C and D, and hence we have sin A into cos B, sin A into cos B equal to half of sin of A plus B plus sin of A minus B. Next, cos A into sin B, cos A into sin B is equal to half of sin of A plus B. So when we subtract these two compound angle formula, we get that is the second term factors, sin of A minus B. Next, cos A into cos B. We know that both cos ratio, so in terms of factors, they are in the compound angle formula cos. Cos of A plus B plus cos of A minus B. Next, sin A into sin B. Sine A into sine B, it is equal to minus half of cos of A plus B. So minus cos of A minus B. Even this can be represented as plus 1 by 2 into, we have to interchange the factors. Take multiply with minus sign. Cos of A minus B minus cos of A plus B. So these are the four results where we convert the product of two trigonometric ratio into the sum or difference. In the above results, if you replace A plus B, we know that the sum of two angles is again an angle, and the subtraction of two angles is again an angle. You take A plus B equal to C and A minus B equal to D. Then solving these two, when we add these two, we get 2A equal to C plus D. So therefore, A equal to C plus D divided by 2. And similarly, when we subtract these two, we get B equal to C minus D divided by 2. We have to replace A plus B equal to C and A minus B equal to D, and A equal to C plus D divided by 2 and B equal to C minus D divided by 2 in the above results, and you consider these results, that is you write RHS of this result to the left side and the LHS to the right side, then we get the results as above, as below. Sine of A plus B, instead of A plus B, you take it as sine C. Instead of A minus B, you take it as D. That is sine C plus sine D. Then we have to cross multiply. We get 2 times sine A. Instead of A, we have to write C plus D divided by 2. So cos B, B instead of B, we have to write C minus D divided by 2. Similarly, the second formula it becomes sine C minus sine D, that is equal to 2 times, the first factor is cos. A means we have to replace it by C plus D divided by 2, and B we have to replace it by C minus D divided by 2. Next, the third result it becomes cos C minus cos D. Cos C minus cos D, we get twice, that is cos of C plus D divided by 2 into cos of C minus D divided by 2. So similarly, we have, this is plus, cos C minus cos D. Minus cos D, it is equal to fourth result, minus 2 times sine A sine B. So A is nothing but C plus D divided by 2 and B is nothing but C minus D divided by 2. So these are the results where the sum or difference of two ratios, they can be converted into product or the factors, in terms of factors, or the product of two ratio. So those results we have, the product of two trigonometric ratios can be expressed in terms of sum or difference of ratios. So here these four results it gives, the sum or difference of the ratios, it can be converted into or transformed into the product of the ratios. So here these formulae which are in trigonometry, they are very important for the calculus part, that is differentiation as well as integration, as well as in inverse trigonometric functions. Even we are going to differentiate the inverse trigonometric functions. In that chapter also, we are going to differentiate the inverse functions. So now we have to consider, before starting the inverse trigonometric function, so first we should know that inverse of a function. So inverse of a function, for a given function, the inverse of a unique function, another function, exists only if the given function is a bijective function. Then before that, we should know what is a bijective function. In the first chapter of second PUC, we have studied about the relations and functions. So in that function particular unit, we have studied about different types of functions. So there we have studied one function as well as onto function. If the given function satisfies both one as well as onto, then there exists another function, a unique another function. So that function, it is called as, that is the inverse of the given function. So here, so one function means a function f from x to y. It is said to be one function if distinct elements in the domain have distinct images in its codomain. So that is called as a one function. Distinct elements in the domain of the function should have distinct images or different images in its codomain. Then we call that function as one function. Next, a function f from the set x to y, it is said to be an onto function if every element in the codomain have a unique distinct image, that is the pre-image in its domain. Every element in the codomain, they must have the pre-image in the domain. So then we call such function as onto function. When we combine those two results, then a function f from set x to y, it is said to be an onto function or the bijective function. So it should satisfy both one as well as onto function. So by the basic concept for the bijective function here, so the number of elements in the domain and the number of elements in the codomain, they must be same. If the set x contains 4 elements and y contains 4 elements, then these 4 elements, they must be associated to the different elements in the codomain. So therefore, the number of elements in domain and codomain, they must be same, so which satisfies one and onto. And hence, the codomain, it is equal to the range of the function. So therefore, in that chapter, instead of codomain, we consider it as the range. So therefore, if the given function f from x to y is one and onto, that is bijective function, such that f of x equal to y, such that f of x equal to y, so where x belongs to the domain and y belongs to the codomain, which is nothing but range because it is an onto function. So such that f of x equal to y, then there exists an unique function, that is g, so which is defined from y to x. So such that g of y, it is equal to x. So where small x it belongs to capital X, that is the set, and y belongs to, so that is y. So here x belongs to x or g of y it belongs to x. Both are same here. So then g, it is called as the inverse of the function f. Then g is called as the inverse of the function f. So symbolically it is denoted by g, it is equal to inverse of f. So now after defining the inverse of a function, so now we should come to the trigonometric functions. So in this unit, inverse of a function, so now we have the two basic results. That is the two basic results that we have, that is nothing but, that is f inverse of f of x, it is equal to x, and f of f inverse of y, it is equal to y. We have these two results, that is f inverse of x equal to x and f inverse of y equal to y. So in f inverse, in place of f inverse, we can consider it as g, because according to this definition, f inverse of f is nothing but g. So therefore we get the result g composition f of x or g of f of x, it is equal to x, and f composition g of y equal to y, or f of g of y, it is equal to y. So here instead of f inverse, we have to replace it by g, then we get in terms of f and g. So now, before starting the inverse trigonometric functions, so first we should know about the trigonometric functions. We know that all the trigonometric functions, they are not bijective functions in their actual domain. So, and hence here in this chapter, our aim is to we have to apply the restrictions on that domain and ranges of the trigonometric functions such that we can define the inverse of all the functions. Then what restrictions we have to consider here? So to make the given trigonometric functions, to write their inverses. So that is our aim here in this chapter. That is what we are going to study about the inverse trigonometric functions. So also that is here we have to first you consider, that is the sine function. So sine function, it is sine function, it is a mapping from the set of real numbers to the closed interval -1, +1. So R, the domain of sine function is R, and the range of sine function is the closed interval -1, +1. Now if we consider this domain as whole, that is the real numbers, then it doesn't become bijective function. Let us see how it doesn't become a bijective function. So here sine function, sine, we have to take an element x here such that sine x, it is associated to y, that is sine x equal to y. Here for this trigonometric functions, x should be, we have to consider the angles. You consider the quadrant angles. So 0 degree, pi by 2, pi, 3 pi by 2 and 2 pi. So here we know that sine 0 degree is nothing but 0. It is associated to 0. The image of an element, or in other words, we can express it as the image of an element 0 under the sine function is nothing but 0. So now sine 90 degree, it is nothing but 1. Sine 180 degree is nothing but 0. Sine 270 degree, it is nothing but -1. Again, sine 2 pi, it repeat ಆಯ್ತು ಮತ್ತೆ ಇಲ್ಲಿ. Again, sine 360 degree ಅಂದ್ರೆ ಅದು ಕೂಡ 0 ಇರೋದ್ರಿಂದ, so 0 ಗೆ ಅದು ಮ್ಯಾಪ್ ಆಗುತ್ತೆ. Here 0 degree, 180 degree and 360 degree. ಈ ಮೂರು ಎಲಿಮೆಂಟ್ಗಳು ಡೊಮೇನ್ ಅಲ್ಲಿ ಬೇರೆ ಬೇರೆನೇ ಇದೆ. That means distinct elements in the domain, they have the same image. ಈ ಮೂರು ಬೇರೆ ಬೇರೆ ಎಲಿಮೆಂಟ್ ಗಳಿಗೆ ಸೇಮ್ ಇಮೇಜ್ ಇರೋದ್ರಿಂದನೇ ಆ ಸೈನ್ ಫಂಕ್ಷನ್ ನಮಗೆ ಬೈಜೆಕ್ಟಿವ್ 1-1 ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಲ್ಲ. And hence in its actual domain, if you consider whole domain, that is actual domain, the sine function, it doesn't becomes, that is 1-1 function means it doesn't becomes bijective function. And hence we cannot study about their inverses. So if we consider the whole domain of sine function, and hence we have to restrict we have to restrict the domain and the range of sine function such that it must become bijective function. Then how we have to restrict? So such that it becomes the bijective function. So now the domain of R we have to consider, or the domain of R, that is of the sine function, it should be restricted to any of the intervals, that is close interval minus pi by 2 comma plus pi by 2. ಇದರ ಹಿಂದಿನ ಒಂದು ಇಂಟರ್ವಲ್ ತಗೊಳ್ಳೋದಾದ್ರೆ that is minus 3 pi by 2 comma minus pi by 2. ನೆಕ್ಸ್ಟ್ ಇನ್ನು ಮುಂದೆ ಬೇರೆ ಹಿಂದೆ ಎಲ್ಲ ಇಂಟರ್ವಲ್ಸ್ ಗಳಿರುತ್ತೆ. ಇದನ್ನ ಒಂದು ಮುಂದಿನ ಇಂಟರ್ವಲ್ ಬರ್ಕೊಳ್ಳೋದಾದ್ರೆ so it becomes pi by 2 comma 3 pi by 2 and so on. ಇನ್ನು ಇಂಟರ್ವಲ್ಸ್ ಗಳು ಬರೀಬಹುದು. ಸೊ ನಾವಿಲ್ಲಿ ಬರೇ 3 ಮಾತ್ರ ಇಂಟರ್ವಲ್ ಗಳನ್ನ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. So here the domain of sine function should be restricted to these intervals. Now in each of the interval, now the sine function, it becomes bijective function. So ಇಲ್ಲಿ ನೋಡಿಕೊಂಡ್ರೆ ನಮಗೆ sin 90 degree 1 plus 1 range ಅಲ್ಲಿ ಇದೆ. Then sin of minus 90 degree is minus 1, ಅದು ಕೂಡ ಅಲ್ಲಿದೆ. So now it becomes bijective function. In these intervals, the sine function, it becomes bijective function. So now corresponding to the each interval, so we can write the inverse for the sine function. So inverse of the sine function, it is denoted by sine inverse. Inverse of sine function, or it is also called as arc sine function, ARC. So this is nothing but arc sine function. So inverse, we should know that sine inverse, it is not equal to 1 by sine. So now we have to restrict the domain of sine function to these intervals, so such that in each of the interval the sine function, it becomes bijective function and the range will be the same. So domain anna ee interval ಗೆ ನಾವು ಡಿವೈಡ್ ಮಾಡ್ಕೊಳ್ತೀವಿ, range ಮಾತ್ರ ನಮಗೆ ಎಲ್ಲಾ ಇಂಟರ್ವಲ್ ಅಲ್ಲೂ ಸೇಮ್ ಇರುತ್ತೆ. Now corresponding to the each interval, we can write the inverse for the sine function. That is, now sine inverse, it is a function from, f is a function from x to y. If it is bijective function, there exists another function g, so which is the mapping is from y to x, domain range interchange agutte y to x. Ade tarane, so close interval minus 1 comma 1 to any one of the intervals, we can write the inverse for the sine function to any one of the intervals as the range. So now we can take here as, that is minus 3 pi by 2 comma minus pi by 2, so mere etc. Or we can consider as minus pi by 2 comma plus pi by 2. Even we can define sine inverse in this interval also. So or sine inverse, so we can define in this interval also for that interval. So 2, that is pi by 2 comma 3 pi by 2 and so on. In each of these intervals, we can define the inverse for the sine function. And here the domain, it becomes the close interval minus 1 comma plus 1, and the range, it is any one of the intervals, so written above, defined above. In particular, so the branch with the range, where we consider as the close interval minus pi by 2 comma plus pi by 2, if the range for the sine inverse function, if we consider it as the closed interval minus pi by 2 comma plus pi by 2 and the domain is closed interval minus 1 comma plus 1, then we call that branch as the principal value branch range of sine inverse function. The branch with the range taken as closed interval minus pi by 2 comma plus pi by 2, it is called as the principal value branch range of the sine inverse function. So other ranges, they are called as branches of sine inverse function. But in particular, if we consider the range as, so the closed interval minus pi by 2 comma plus pi by 2, so then it is called as the principal value branch range. So here while solving the problems, that is, here we have to be very conscious about the range of the inverse functions. Range, domain and range of the inverse functions. Because we have to get the results of the inverse functions according to their principal value branch range. So we have to get the results in this interval. That is the value in this interval. So now here, after that is a sine inverse function. Hence we have sine inverse as a function. So from the closed interval minus 1 comma plus 1, this is the domain, and the range we have to take it as the principal value branch range. According to the definition of inverse of a function, so we can write, we have sine of sine inverse x. It is taken as x only if x belongs to the closed interval, that is minus 1 comma plus 1. If and only if x should belongs to the closed interval minus 1 comma plus 1. Similarly, sine inverse of sine x, it is taken as x only if, so ಇಲ್ಲಿ ಹೊರಗೆ sine inverse ಇದೆ, ಹಾಗಾಗಿ the answer it should be in terms of the range means here angle. So therefore the value of x, it should belongs to the closed interval minus pi by 2 comma plus pi by 2. So according to the definition of inverse of a function, we can write these two results, and we should know the condition for restriction for x here. That is sine of sine inverse x, it is taken as x if minus 1 x belongs to closed interval minus 1 comma plus 1. Sine inverse of sine x, it is equal to x if minus pi by 2 x should belongs to the closed interval minus pi by 2 comma plus pi by 2. So totally about the inverse of sine function, if we sum up, so we have this result. Sine inverse, it is a function from closed interval minus 1 comma plus 1 to minus closed interval minus pi by 2 comma pi by 2, which is called as the principal value branch range. And we have these two results. So this is about the inverse of sine function. Let us draw the graph after studying about the inverse of cos function. We know that cos function again it is not bijective function. So it is not bijective function in its original domain. We know that cos function, it is a mapping from, it is a function from R to close interval minus 1 comma plus 1, where R is nothing but the set of real numbers. Similarly, as we studied in the sine function by considering the quadrant angles, so there two angles, they are associated to the same element. Here also the two angles will also, two or more angles will be associated with the same element, and hence it doesn't becomes, that is the bijective function. And hence we have to restrict the domain of cos function to any one of the intervals defined below. So that is, we have to restrict the domain R of the cosine function, cos function, to any one of the intervals where in each of these intervals the cos function, it becomes bijective function. It becomes bijective function. So in one mark question, they will ask, that is, other than, this is called as the principal value branch range of sine inverse function. One mark question will be asked, that is, other than the principal value branch range, write the range other than the principal value branch range for sine inverse function. Then we have to accept this interval. We have to write other intervals, that is pi by 2, 3 pi by 2, or so ಇದರ ಹಿಂದಿನ ಒಂದು ಏನಿರುತ್ತಲ್ಲ ಅದನ್ನು ಕೂಡ ತಗೋಬಹುದು. ಸೊ ದಟ್ ಈಸ್ ಆರ್ ಅದರ ಹಿಂದಿಂದ ಬರೆಯೋದಾದ್ರೆ -3 pi by 2, -pi by 2. ಸೊ ಇನ್ನೂ ಒಂದು ರೀತಿಯಲ್ಲಿ ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ ಅವರು, write other than the principal value branch range of the sine inverse function which lies in 0, 2 pi ಅಂತ ಕೇಳ್ತಾರೆ. ಅವಾಗ ನಾವು ಇದನ್ನ ಬರೀಲಿಕ್ಕೆ ಬರಲ್ಲ, ಇದು ನೆಗೆಟಿವ್ ಆಂಗಲ್ಸ್ ಇದೆ, ಅದಕ್ಕೆ ನಮಗೆ ಪಾಸಿಟಿವ್ ಅಂದ್ರೆ ಇದು 0 ಇಂದ 2 pi ಅಂದ್ರೆ ಒಂದು ರೌಂಡ್, therefore we have to write this branch. ಇದನ್ನ ನಾವು ಬರೀಬೇಕಾಗುತ್ತೆ. ಸೊ ಆ ತರ ಒನ್ ಮಾರ್ಕ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಅವ್ರು ಏನ್ ಕಂಡೀಷನ್ ಮೇಲೆ ಕೇಳ್ತಾರೋ ಆ ಬೇರೆ ಇಂಟರ್ವಲ್ ಅನ್ನ ನೋಡ್ಕೊಂಡು ನಾವು ಅದಕ್ಕೆ ಆನ್ಸರ್ ಅನ್ನ ಬರೀಬೇಕು. ಬಟ್ ಪ್ರಿನ್ಸಿಪಲ್ ವ್ಯಾಲ್ಯೂ ಬ್ರಾಂಚ್ ರೇಂಜ್ ಅಂತ ಕೇಳಿದಾಗ ಮಾತ್ರ ಇದನ್ನೇ ಬರೀಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ಒನ್ ಮಾರ್ಕ್ ಕ್ವಶನ್. ನೋಡಿ, ಒನ್ ಮಾರ್ಕ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ನಮಗೆ ಯೂಶಲ್ ಆಗಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅವ್ರು ನಮಗೆ ಈ ತರ ಈ ಅಷ್ಟು ಇನ್ವರ್ಸ್ 6 ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದಕ್ಕೆ ಅದು ಪಾಸಿಬಲ್ ಕ್ವಶನ್ ಆಗಿ ಕೇಳ್ತಾರೆ ಅವರು. ಸೊ ಈಗ ಕಾಸ್ ಫಂಕ್ಷನ್, ಸೊ ಅದರ ಡೊಮೈನ್ ಅನ್ನ ನಾವು ಇಂಟರ್ವಲ್ ಗಳಾಗಿ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. ಹೇಗೆ ಡಿವೈಡ್ ಮಾಡ್ಕೋಬೇಕು ಈ ಇಂಟರ್ವಲ್ ಗಳನ್ನ ಅಂದ್ರೆ, ಪ್ರತಿ ಒಂದು ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ ನಮಗೆ ಈ ಕಾಸ್ ಫಂಕ್ಷನ್ ಬೈಜೆಕ್ಟಿವ್ ಫಂಕ್ಷನ್ ಆಗಿರ್ಬೇಕು. ಅಂದ್ರೆ ಇಟ್ ಶುಡ್ ಸ್ಯಾಟಿಸ್ಫೈ ಬೋತ್ 1, 1 and on 2 condition. Therefore, the domain, the original domain, it is we have restricted to close interval 0, pi, pi, 2 pi, etc. And in ಮುಂದಿಂದು 2 pi, 3 pi, ಇದು ಒಂದು ಹಿಂದಿಂದು -pi, 0, ಇದರ ಹಿಂದಿಂದು -2 pi, -pi, ಅದು ಕೂಡ ತಗೋಬಹುದು. So in each of these intervals, the cosine function, it becomes bijective function, and hence we can define the corresponding to each interval, we can define the inverse for the cosine function, that is the cos function. So now cos function, it is a cos inverse, it is a mapping function from, that is close interval -1, +1 to, now you write this interval, we can take -pi, 0, or we can, idu domain same irutte elladukku, that is 0, pi ide idu next, or we can consider the next that is the range, that is pi, 2 pi, so etc. so illu mele etc. so illi cos inverse, ನಾವು ಯಾವ್ದಾದ್ರೂ ರೇಂಜ್ ಗೆ ನಾವು ಯಾವ್ದಾದ್ರು ಇಂಟರ್ವಲ್ ಅನ್ನ ತಗೊಂಡು ನಾವು ಕಾಸ್ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಅನ್ನ ಡಿಫೈನ್ ಮಾಡ್ಕೋಬಹುದು. ಬಟ್ ಇನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್ ದ ರೇಂಜ್ ಆಸ್ ದ ಕ್ಲೋಸ್ ಇಂಟರ್ವಲ್ 0, pi. ಸೊ ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದಿಸ್ ರೇಂಜ್, ದೆನ್ the branch, the principal value branch range for cos inverse function, it is taken as the close interval 0, pi. So this range, it is called as the principal value branch range for the cos inverse function. Here the domain will be same. So if you consider other ranges also, so then the branch of it is called as simply the branch of the cos inverse function. Cos inverse, it is also called as arc cosine function. Inverse of cosine function, it is also called as arc cosine function. So now, therefore, after summing this one, so therefore cos inverse, it is a function from, so close interval -1 comma +1 to, that is close interval 0 comma pi. This is called as principal value branch range. Other ranges, they are called as simply the ranges of the cos inverse function. So therefore, according to the definition of inverse of the function, we have cos inverse of x. It is taken as x only if x belongs to the closed interval -1 comma +1. And cos inverse of cos x. So it is taken as x only if x should belongs to close interval, the principal value branch range, that is 0 less than or equal to x less than or equal to pi. So that is finally we should know this result. So that is the inverse of cosine function. It is defined from, that is close interval -1 comma +1 to, that is the close interval 0 comma pi, which is called as principal value branch range. According to the definition of inverse of a function, we have cos inverse x equal to x only if x lies in the close interval -1 comma +1, and cos inverse of cos x equal to x only it is taken as x only if x belongs to the close interval 0 comma pi. So therefore, while solving the problems, if the value of x doesn't lies in this interval, with the help of allied angles, cos of that angle, it is reduced to an acute angle. So then the x, it is reduced to an acute angle with the help of allied angles, then we can apply this property. We can apply this result. So that is here we use, that is the application of allied angles here to convert the value of x, that is the angle, so in this range. So ನೋಡಿ ಇಲ್ಲಿ ನಮಗೆ ಅಲೈಡ್ ಆಂಗಲ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಪ್ರತಿಯೊಂದು ಲೆಕ್ಕಗಳನ್ನ ಮಾಡಬೇಕಾದ್ರೆ ಇಲ್ಲಿ ನಾವು ಯಾವ್ದಾದ್ರೂ ಒಂದು ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಯಲ್ಲಿ ಕಲ್ತಿರುವಂತ ಯಾವುದೋ ಒಂದು ಫಾರ್ಮುಲೆ ಅಥವಾ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ನಾವಿಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಅದಕ್ಕೆ ಪ್ರತಿ ದಿನನೂ ನಾವು ಈ ಎಲ್ಲಾ ಫಾರ್ಮುಲಾಸ್ ಗಳನ್ನ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಯಲ್ಲಿ ಬರುವಂತ ಎಲ್ಲಾ ಫಾರ್ಮುಲಾಸ್ ಗಳನ್ನ ಲೆಫ್ಟ್ ಸೈಡ್ ಇಂದ ರೈಟ್ ಸೈಡ್ ಅಷ್ಟೇ ಕಲಿಯೋದಲ್ಲ, ಅದನ್ನ ರೈಟ್ ಸೈಡ್ ಇಂದ ಲೆಫ್ಟ್ ಸೈಡ್ ಕೂಡ ತುಂಬಾ ಕಡೆ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ನಾವು ಮ್ಯಾಕ್ಸಿಮಮ್. ಸೊ ಅದನ್ನು ಕೂಡ ರಿಪೀಟೆಡ್ಲಿ ವಿ ಹ್ಯಾವ್ ಟು ರೈಟ್ ಇಟ್. ಯಾಕಂದ್ರೆ ಅದನ್ನ ನೋಡಿದ ತಕ್ಷಣ ನಾನು ಏನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೋಬೇಕು, ಈ ಫಾರ್ಮುಲಾ ಬಂದ್ಬಿಡುತ್ತದು ಅನ್ನೋದು ಗೊತ್ತು ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಹಾಗಾಗಿ ಪ್ರತಿ ದಿನನೂ ನೀವು ಆ ಎಲ್ಲಾ ಫಾರ್ಮುಲಾಸ್ ಗಳನ್ನ ಮತ್ತೆ ಇಲ್ಲೇ ನಾವು ಡಿಫೈನ್ ಮಾಡಿದೀವಲ್ಲ ಈ ತರದಲ್ಲಿ, ಇದನ್ನ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅನ್ನ ತೆಗೆದು ಇವಾಗ ನೀವು ಓದಿದ್ರೆ ಇದು ಅರ್ಥ ಆಗುತ್ತೆ ಅವಾಗ. ಸೊ ಇದನ್ನು ಕೂಡ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ, ಅದನ್ನ ಮೆಮೊರೈಸ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ನಮಗೆ ರಿಪೀಟೆಡ್ ಆಗಿ ಇವೆಲ್ಲ ನಮಗೆ ಕಂಡೀಷನ್ಸ್ ಗಳು ಆಗ್ತಾ ಇರುತ್ತೆ. ಈಗ ಇದಕ್ಕೆ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಅಂತಂದ್ರೆ, ಇಲ್ಲಿ ಹೇಗೆ ನಾವು 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ನು, ಅದೇ ತರನೇ ಇಲ್ಲೂ ಕೂಡ ನಮಗೆ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಅನ್ನ ಕೇಳ್ತಾರೆ. ಸೊ ಮೊದಲನೇ ಟೈಪ್ ಅಲ್ಲಿ ಯಾವ ತರದ್ ಕೇಳಬಹುದು ಅಂದ್ರೆ, ರೈಟ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ವ್ಯಾಲ್ಯೂ ಬ್ರಾಂಚ್ ರೇಂಜ್ ಆಫ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಅವಾಗ ನಮಗೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಅವಾಗ ನಾವೇನ್ ಮಾಡ್ಬಿಡ್ತೀವಿ, ಕ್ಲೋಸ್ ಇಂಟರ್ವಲ್ 0 ಕಾಮಾ ಪೈ ಅಂತ ಕೇಳ್ತಾರೆ, ಬರ್ದ್ ಬಿಡ್ತೀವಿ. ಸೊ ಯೂಶಲ್ ಯಾಕಂದ್ರೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ, ಬರ್ದ್ ಬಿಟ್ಟಿರ್ತೀವಿ ಅದನ್ನ. ಬಟ್ ಅವ್ರ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ, ಇನ್ನೂ ಒಂದ್ ರೀತಿಲಿ ಕೇಳೋದಾದ್ರೆ, ಸೊ ರೈಟ್ ದ ಅದರ್ ದ್ಯಾನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ವ್ಯಾಲ್ಯೂ ಬ್ರಾಂಚ್ ರೇಂಜ್ ಆಫ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಅವಾಗ ನಾವೇನ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ಅದರ್ ದ್ಯಾನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ವ್ಯಾಲ್ಯೂ ಬ್ರಾಂಚ್ ರೇಂಜ್ ಅಂದ್ರೆ ಇದನ್ನ ಬಿಟ್ಟು ನಾವು ಇದನ್ನಾದ್ರೂ ಆನ್ಸರಿಗೆ ಬರೀಬಹುದು ಅಥವಾ ಇದನ್ನಾದ್ರೂ ಆನ್ಸರಿಗೆ ಬರೀಬಹುದು. ಆದ್ರೆ ಅವ್ರು ವಿಚ್ ಲೈಸ್ ಇನ್ ಕ್ಲೋಸ್ ಇಂಟರ್ವಲ್ 0,2π ಅಂದಾಗ ನನಗೆ ಈ ಇಂಟರ್ವಲ್ ಬರೀಬೇಕು, ಈ ಇಂಟರ್ವಲ್. ಹಾಗೆ ಅವ್ರು ಹೇಗೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಮಾಡಿ ಕೊಟ್ಟಿರ್ತಾರೋ ಒಂದು ಕಂಡೀಷನ್ ಅದನ್ನ ನೋಡ್ಕೊಂಡು ನಾವು ಇದನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಬಟ್ ಅದರ್ ದ್ಯಾನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ವ್ಯಾಲ್ಯೂ ಬ್ರಾಂಚ್ ಅಷ್ಟೇ ಕೇಳಿದಾಗ ನಾವು ಇದನ್ನಾದ್ರೂ ಬರೀಬಹುದು, ಈ ಕಡೆದಾದ್ರೂ ಬರೀಬಹುದು. ಬಟ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಹೇಳಿದ್ರು ಅಂದ್ರೆ ನಾವು ನೋಡ್ಕೊಂಡು ಯಾವ ಇಂಟರ್ವಲ್ ಅದರ ಒಳಗಡೆ ಅವ್ರು ಕೇಳಿರೋ ರೇಂಜ್ ಅಲ್ಲಿ ಇರುತ್ತೋ ಅದನ್ನ ಮಾತ್ರ ಆನ್ಸರ್ಗೆ ಬರೀಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ಅಬೌಟ್ ದ cos inverse function. So now we shall draw the graph of, that is the sine function as well as sine inverse function, which means that the graph of sine inverse function, it can be obtained from the graph of sine inverse function. It can be obtained from the graph of sine function by interchanging x and y axis, which means that if a comma b is a point, if a comma b is a point on the graph of sine function, if a comma b is a point on the graph of sine function, then b comma a, so that means interchanging b comma a, it becomes the corresponding point on, so b comma a comma b is a point on the sine function, then corresponding to this point, so b comma a, by interchanging x and y axis, that concept, it becomes a point on the sine inverse function. Sine inverse function. So now we have to draw the graph of the sine function. If we draw the graph of the sine function, so here you will draw the graph of the sine function. So that is there we can draw the graph of that is the sine function graph. Already you know the graph of the sine function, that is y equal to sin x. So y equal to sin x, we have to give the domain of sine function is nothing but real numbers. So therefore here, and the range, the value of y, it lies in the interval, close interval -1 comma +1, which means that it doesn't exceed above the value 1 and below -1. ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಸೈನ್ ಫಂಕ್ಷನ್ ಇನ ವ್ಯಾಲ್ಯೂ 1 ಗಿಂತ ಜಾಸ್ತಿ ಅಥವಾ -1 ಗಿಂತ ಕಡಿಮೆ ನಮಗೆ ಬರೋದೇ ಇಲ್ಲ. As the values of x increases, the value of the sine function, that means y value, it lies in the closed interval -1 comma +1. So you consider the quadrant angles, that is pi by 2, that is pi, 3 pi by 2, 2 pi. ಎಡಗಡೆ ಭಾಗದಲ್ಲಿ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ ಗಳನ್ನು ತಗೊಳ್ಳೋಣ. ದಟ್ ಈಸ್ -pi by 2, this is -pi, -3 pi by 2. when x ಗೆ angles ಗಳನ್ನು ತಗೊಳ್ತಾ ಹೋಗಬೇಕಿದೆ sin ಫಂಕ್ಷನ್ ಗೆ, sin 0 it is equal to 0. When x equal to 0, then the value of y is nothing but 0. The point it lies here. When x equal to 90 degree, then sin 90 degree is 1. Therefore, the value of y is 1. That is, the point is here. When x equal to 180 degree, we know that sin 180 degree is 0, which means that the value of y is 0. It lies here. When x equal to 270 degree, we know that sin 270 degree is -1. Therefore, the value of y is -1. That means here, it lies here. When x equal to 360 degree, Again, sine 360 degree value is 0. That means y value is 0. So now, here, sine of minus pi by 2. Sine of minus pi by 2 is nothing but minus 1. ಇಲ್ಲಿ ಬರುತ್ತೆ ಪಾಯಿಂಟ್. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಈಗ ಪಾಯಿಂಟ್ಗಳನ್ನು ನಾನು ಜಾಯಿನ್ ಮಾಡಿದ್ರೆ ಸೈನ್ 0 is here ಇಲ್ಲಿದೆ, ಸೈನ್ 90 ಡಿಗ್ರಿ ಇಲ್ಲಿದೆ. ಈ ತರ ಶಾರ್ಪ್ ಬ್ಲೆಂಡ್ ಆಗಿ ಟ್ರೇಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಈ ತರ ಬರುತ್ತೆ. ಸೊ 1 ಗಿಂತ ಮೇಲಕ್ಕೆ ಬರಲೇಬಾರದು. Because maximum value is 1, the minimum value is minus 1. So, ಈ ತರ ಬರುತ್ತೆ graph. This is the graph of the sine function. So, as the values of x increases, so here the value of sine function, it lies in the closed interval, that is minus 1 and plus 1. So, now we know that here one concept avagale na helidaytu. To get the graph of sine inverse function, we have to interchange x and y axis, which means that we have to consider the angles along y axis and the value that is closed interval minus 1 comma plus 1, it will be on the, that is the x axis. So now we shall draw the graph of the sine inverse function. We have to interchange x and y axis here. That means along the y axis we have to take, that is angles. Let us consider only the quadrant angles. So here 90 degree, you take 180 degree, this is 270 degree. Enough to know the graph, only you take 3 or 4 quadrant angles. Here is minus pi by 2 and minus pi and minus 3 pi by 2. Minus 3 pi by 2. So here sine 0. So here we shall now consider, we know that sine 0 equal to 0 implies sine inverse of 0 equal to 0. We know that sine inverse of sine 90 degree equal to 1 implies sine inverse of 1, it is equal to pi by 2. Sine inverse of 1, I think we can't see here, I will write here. So here we know that sine 0 equal to 0 implies sine inverse of 0 equal to 0. So sine 90 degree, it is equal to 1 implies sine inverse of 1 equal to 90 degree. We know that sine 180 degree equal to 0 implies again sine inverse of 0, we can take it as pi. Here also it becomes pi for pi. Therefore that range, nami principal value range ola baralla, just we are going to draw the graph. Next sine 270 degree, that is 3 pi by 2 equal to minus 1 implies sine inverse of minus 1, it is equal to 3 by 2. This is taken only to draw the graph. So here sine 0 is 0, sine inverse of 0 is 0. Sine inverse of 1, x value 1 idre 90 degree. Next, this is the 1 maximum, here minimum value is minus 1. So if you draw the graph, again it comes to 0. Here 0, next minus 1, again it here. So minus 1, again it goes like this. Again so this is the graph of the sine inverse function. Here in the closed interval, that is the principal value branch range, it is nothing but minus pi by 2 to plus pi by 2. That is this graph. You darken that part, the principal value. The shaded or the darkened line, it represents the principal value branch range of the sine inverse function. So this is the graph of the sine function by interchanging x and y axis. So we get the graph of the sine inverse function. Here the darkened parted line, so it represents the principal value branch range of sine inverse function. This is the graph of the function y equal to sine x, and this is the graph of the function y equal to sine inverse of x. Sine inverse of x. When we draw V1, we can draw, so in the same coordinate axis, so we can draw both the graph. So that we shall continue it in the next class. So dear students, here important note is that you have to practice the formulas of all trigonometric function, formula of trigonometric functions. So every day until you can recognize by seeing it, or we have to write repeatedly. So then you can remember what substitution we can take by seeing that function. So you should be very familiar. ನೀವು ಒಂದ್ಸಲ ಬರೆದು ನನಗೆ ಬರುತ್ತೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋದೇ ಇಲ್ಲ ಇಲ್ಲಿ. ಯಾಕೆಂದ್ರೆ ನಾವು ಎಕ್ಸಾಮಲ್ಲಿ ಟೈಮ್ ಉಳಿಸ್ಬೇಕು ಅಂತಂದ್ರೆ ಸೊ ನಾವೇನ್ ಮಾಡ್ಬೇಕು, ಅದನ್ನ ತಕ್ಷಣಕ್ಕೆ ಜ್ಞಾಪಕ ಬರಿಬೇಕಾದ್ರೆ ಸೊ ನಮಗೆ ಅದು ನೋಡಿದ ತಕ್ಷಣನೇ ಏನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಂಡು ಬರಿಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಾಗ್ಬೇಕು. ಅದಕ್ಕೆ ಎವ್ರಿ ಡೇ ಯು ಪ್ರಾಕ್ಟೀಸ್ ದ formulae and all the basic concepts of this inverse trigonometric functions. So